Right. Hopefully you've had a good break. I feel revived and invigorated to look at our next module, which is going to be on the first scientific revolution that occurs immediately following the Higher Renaissance. The Renaissance itself comes to an end. This period of enormous cultural, artistic creativity comes to an end as a consequence of the invasion of Italy by France and by Spain, who are fighting it out with each other over Italian territory. And that, of course, causes the Renaissance to experience many, many difficulties and problems. But there's also another process that occurs, which brings the Renaissance to a close, which is that a movement arises in Germany which protests against the Catholic Church. The basis for that protest is ironically also linked to the Renaissance. During the Renaissance, the Church is undertaking massive projects of art and sculpture and other things. One of the big projects that the Church is undertaking is the building of the Basilica of St. Peter's. That's the Basilica, that's the church, जहाँ पे पोप की अगर आपने कोई तस्वीर देखी और बहुत सारे लोग सामने होते हैं तो और पोप खड़ा होता है या खड़े होते हैं तो लोग बहुत सारे सामने होते हैं और यूं करके कर्व में बिल्डिंग है. That's the Basilica of St. Peter. उसको वो रिन्यू कर रहे, दोबारा बना रहे. Julius II started it, Leo X continued it. These are the names of the popes, and they needed a lot of money to do all this building. They got Michelangelo to redo the Sistine Chapel. They needed all these artists to do all this work. And artists को इतने पैसों की जरूरत नहीं होती थी because they were using paints. But where architecture was concerned, where buildings were concerned, there was a lot of money needed. One of the things that the church started doing to raise money, well, the first thing, of course, they did was that they collected taxes. They collected as much taxes as possible. This never makes people very happy in politics here, whenever you raise taxes. Be forewarned, maybe the present government may raise taxes. Let's see. But the second thing they started doing was they began to sell what are called indulgences, which was basically a way to make money in order to support the building of St. Peter's Basilica. And indulgences meant that you could actually pay your way, you could pay for your sins. You could buy an indulgence from the church, you would pray, you would give a donation to the church, and in exchange, the church would say that you are hereby absolved of XYZ sin that you committed. This became very quickly a very big business. As this became a big business and as the church got rich and it invested into developing new buildings and architecture and so on, it also caused many people to become very angry with the church. Number one, they were being taxed more. They were poorer. Number two, they saw the practice of indulgences as being biased because it meant that rich people could buy out their sins and could therefore buy their way into heaven. And this was struck ordinary people as being very, very unjust and unfair. So it resulted in a movement led by a man named Luther, called the Protestant movement. It gets the name Protestant because they were protesting. Protestants. So this was the Protestant Reformation, beginning in 1517 and the 16th century. And it spread very rapidly, and soon it became very destructive. It also aligned itself to this other movement called the Peasant Wars of 1525, where the peasants revolted now not only against the church, but even against the nobility, against the feudal lords. So now to crush this movement, the church was not happy that this was going on, the Catholic Church, that all these people were protesting. So to crush this dissent, they began what is called the Counter-Reformation. I think you might want to write that down. Reformation and Counter-Reformation. In the Counter-Reformation, the church reversed its earlier, more humanist and liberal policy and became much more strict, much more orthodox, and much more unwilling to listen to dissent. And this led to the clash between the church and not only other religious movements within Christianity or outside of Christianity, but it also led to a clash between people who were inspired by the Renaissance, a Renaissance that the church has begun, were inspired by the Renaissance but wanted to continue it further, whereas the church now said, enough, we've done as much Renaissance as we could, we are now going to be a little more strict. So this caused a clash. When the church lifted its patronage away from the Renaissance arts and went into the Counter-Reformation mode, and as a consequence also, secondly, of the invasion of Italy by France and Spain, the Italian Renaissance came to a close. And Italy did not recover from the Counter-Reformation for at least 200 more years. And Italy, then for 200-300 years, is no longer at the forefront of the arts and the sciences and everything. The focus begins to shift elsewhere. Italy starts this process, but is unable to continue it. But the process now has already started traveling across Europe and so on. And it engenders in turn an interesting and new conflict, which is referred to in history as the Scientific Revolution, beginning in 1550 and coming to a close in about the 1700s. Anybody heard of this Scientific Revolution? You must have heard of the second Scientific Revolution, at least the one after in the 20th century, etc. So this is the first one. How modern science developed. Do you know this Baba sitting in the diary over here? Good. Yes, that's Galileo. So modern science dates from that mighty epoch which Germans termed the Reformation, French termed the Renaissance, and the Italians the Conquiscenta. It begins on the last half of the 15th century. Now we are going to look at the birth of modern science. This sounds a bit strange at first. What do you mean, sir, by modern science? And how is it different from medieval or ancient science? Medieval science, you see, was very much enmeshed with theology. It was very much part of theology. In fact, they would call it the handmaiden of theology. That was an expression that was used at that time. Science is the handmaiden of theology. So the limits of science tended to be that science was used only for the purpose to prove the Bible correct. It was never used for its own sake or own purpose. It was never used, for example, to just improve lives or discover things or whatever. Its main function was to prove that what the Bible had written, what the Bible had stated, was proven by facts and figures, evidence. So it's not the case that science did not exist before modern science. It's not the case that people were not curious, that people were not looking at various things, etc. Of course it did. Even the church encouraged it. The church had many monks, etc., who would work with plants, etc. Mendel is a great example of the guys who discovers, how plant reproduction occurs, which leads to an understanding of genetic theory much later on. Sorry?
He was the father of genetics.
Yes, that's right, absolutely correct. And he was a monk, so he's part of the church. So there are many examples of this sort, but as I said previously, they were within the framework of theology. You could not go beyond the framework of theology. And in many instances we see similar efforts in the context of science in Pakistan today. For example, we see people who talk about the scientific miracles of the Holy Quran. They use science to argue the position that the Holy Quran is a scientific book. On the other hand, are people who say, like Javed Gandhi, for example, who say that the Quran is not a scientific or a historical book in the way that we understand science and history and social sciences today. It's a work on the ethics of humanity. It's a revelation on the ethics of humanity. And so on. So this is debate within Islam going on as well, or within Muslim civilization. Now some interesting things are happening and developing in Europe. One is the development of what we call modern, what's this big word over here? Bourgeois society. Now the word bourgeois basically means middle class in French. So the middle class is now developing and coming to the fore. Royalty with the support of the burghers of the town. Burghers? ये को बर्गर होते हैं, एक वो होते हैं ना, कोई बर्गर होते हैं, कोई बन कबाब होते हैं. बर्गर कौन से होते हैं? वो जो ओ हाँ, जो पीटीआई को सपोर्ट करते हैं वो बर्गर होते हैं, और जो पीएमएलएन को सपोर्ट करते हैं वो बन कबाब होते हैं. Am I right? Burghers here are basically traders, peasants who became traders. They broke with the power of the feudal nobility and established the great monarchies, based essentially on nationality, within which the modern European nations and modern bourgeois society came to develop. The peasant war in 1525 in Germany plays an important role because it begins a class struggle and leads to the development of the modern proletariat and so on. So now with Renaissance, you see that I told you already that manuscripts from the fall of Byzantium, antique statues dug out from the ruins of Rome, a new world was revealed to the astonished West, that of ancient Greece. And this caused the dictatorship slowly over time, caused the dictatorship of the church over men's mind to be shattered. Germans adopted Protestantism, the Latins adopted free thought that was taken over from the Arabs, and nourished by the newly discovered Greek philosophy, it prepared the way for the materialism of the 18th century. This beautiful painting that you see is called the School of the Athens. And you only see one part of it. Here you can see this little Baba pointing upwards. That Baba is supposed to be Plato. Aristotle is the other Baba who's standing next to him, and he's doing this pointing downwards. They are in the center of this great debate. And all the great philosophers are over here. I put all the great Greek philosophers and some of the philosophers of the Renaissance are over here. I put this section over here for you because I wanted to show you this figure over here, this man over here. Now this is a painting on a wall of one of the, within the Vatican. The chapel within the Vatican is called the Sistine Chapel. It's one of the most revered sites of Christianity. So they asked the one artist whose name is Raphael, one of the Teenage Mutant Ninja Turtles, to paint this painting. He painted it on the wall. And this figure over here that you see is Ibn Rushd, because Raphael and others felt that he had made such an important contribution to Western civilization that he should be also part of this great painting. This man over here drawing the painting, I believe, is Socrates. Ibn Rushd is looking over the shoulder of Socrates to see what he is painting. So a great tribute to the contribution that Ibn Rushd made to the rediscovery of Greek philosophy. Ibn Rushd wrote commentaries on Aristotle. He wrote it in response to Al-Ghazali. Al-Ghazali wrote a book called The Incoherence of the Philosophers. And Ibn Rushd wrote a response to that many, many years later, naturally, called The Incoherence of the Incoherence. Or, to put it grammatically more correctly, The Incoherence of the Incoherent, in which he tried to refute what Al-Ghazali had written. Al-Ghazali, of course, had tried to refute what Ibn Sina and Al-Farabi had developed and Al-Kindi had developed. So this debate was going on. So, as I told you, the Renaissance man was somebody who lived a very practical life. They engaged in many different things. They were painters, they were writers, they were thinkers, they were artists, they were mathematicians. They tried always to master several languages and a number of fields. Da Vinci is the ultimate Renaissance figure. He's a painter, mathematician, mechanic, engineer, and physicist. Durer, engraver, sculptor, architect, and invented a system of fortification. Machiavelli is a statesman, he's a historian, he's a poet, he's a military author. Luther criticized the church, created modern German prose, composed music. This was the spirit of the Renaissance. They took sides in the fight. They were activists, they were politicians. They were not armchair philosophers or drawing room philosophers. But they were men of action. one by speaking and writing, another with a sword, many with both. Hence the fullness and force of character that makes them complete men. For them, these were not abstract ideas. Oh, that's an interesting idea. Oh, this is also an interesting idea. तुम भी ठीक हो, मैं भी गलत नहीं. I've seen नहीं था. No, for them, these were life and death questions. The future of humanity itself, they felt, was at stake. And natural science developed as a revolution within this revolution. It developed directly out of the humanist, modern natural science, develops directly out of the humanism and the liberal arts that developed from the Renaissance. Now, both the major religions of Europe at the time, Catholicism, as well as the Catholic faith, as well as Protestants, were quite antagonistic to these new rebels that called themselves scientists. And they both outdid each other to persecute these new scientists. Calvin, John Calvin, a very important preacher who developed Calvinism in Amsterdam, had Servetus burnt at the stake when the latter was on the point of discovering the circulation of blood. And he kept him roasting alive for 2 hours, 2 ghante. Acha stake ban gaya hoga. For the Inquisition, at least, it sufficed to have Giordano Bruno simply burned alive. So you see that at that time, being a scientist was not very healthy for your, was not very good for your health, unless you wanted to become a hamburger. Bad joke, sorry. But it was a very serious thing to be a scientist. And so people risked their lives to become scientists. I want to begin talking about the first big rebel who starts the revolution of natural science, this guy, Nicholas Copernicus. You see, the ancient Greeks believed, Ptolemy and Aristotle and others believed. Sorry? Yes, that's right. They believed that the Earth was at the center of the solar system and everything else was revolving around it. Why did they believe that?
Because they thought that creation of man was the sole purpose of the universe.
That's true, yes. I mean, that's the Christian doctrine. But there's a very simple explanation for why they believed it. Much simpler than that. That's a very complex explanation.
They saw the sun coming up.
Exactly. If you stand and you look at the sky, everything is revolving around you. Yeah, so it's very simple for you to say, oh, look, everything is revolving around us, right? It's not very complicated. It was a straightforward observation. But here's the interesting thing. Everything was revolving around you. But some things, 5 things in particular, were not just revolving around you, they were revolving around themselves. Did you know this? If you look at the sky and you see the Milky Way, the stars and their formation are fixed and they move across the sky. We have been fascinated by the stars since forever. Sadly, we are no longer fascinated by them. I don't know what the situation in Karachi is. But in Lahore, इतनी haze है कि रात को कोई सितारे नजर नहीं आते. जब मैं छोटा था तो रात को कोई सितारे नजर आते. मगर अब हमने इतनी लाइट पोल्यूशन भी है और दूसरी पोल्यूशन भी है, फॉग भी है, स्मॉग भी है, कि अब कोई सितारे नहीं नजर आते. But if you go to Gilgit or Gunza or someplace up in the north, you see all. Karachi नजर आते? आज रात को मैं चेक करूँगा. By the way, I went to Nepal and I went to Italy. One of the things that strikes you the first when you go to a foreign country is how blue the sky is. और पाकिस्तान में मैं बार-बार लोगों से पूछ रहा हूँ कि why is the sky so grey? It's like really this grey color which is like really depressing. So you all are scientists, you have to figure this out for me and tell me why is the sky turned grey? It's supposed to be blue. What's going on? And back to the story. We've been fascinated by the stars since forever. They are fascinating. They twinkle in the sky. When I want to put my daughters to sleep, what do I sing them? I sing them, twinkle, twinkle, little star. How I wonder what you are. Wow, I mean, that's really true for all humankind. We've been wondering what the stars are. We've been thinking about them. Because they're beautiful and fascinating, especially on a clear day. Now, the thing about the stars that's very interesting is the Babylonians were some of the first people to figure out the patterns of the stars. And they ascribed to them, they looked at the sky, they looked at various formations. And they started naming the formations. Of course, the formations don't change. And so they named them Aries, and Libra, and Cancer, and Gemini, and blah, 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 blah. And they also had the view that the way in which the stars were moving in relation to the sun, that had some impact on our lives. They didn't have the concept that the stars were planets. They had different concepts, that these were beings of some sort. Later on, as Christianity developed, and even to some extent, in Islam, people began to think, Judaism and other religions as well, people began to think that the stars were really angels. They thought ye farishte, and that they're moving around the earth, etc. And so on. So, for the ancient Greeks, even when Anaxagoras once said to them, there was an ancient philosopher, उसने कहा सितारे भी उसी चांद सितारे सियारे वगैरह की उन्हीं चीजों से बने हुए उसी मादे से बने हुए जिस मादे से ये दुनिया बनी हुई है. Oh my God! The Greeks thought this was blasphemous. उसको उन्होंने शहर से बाहर निकाल दिया. इसको तो बाहर तो पागल आदमी इसको पता ही नहीं सितारे क्या होते हैं. Anyway, so there was this view. Now this view had also become the view of the official view of the Catholic Church. They had taught it for 1,000 years. It was part of their doctrines. They couldn't really change it. But here's the interesting thing about this view. If you ever observe the sky, marker there. If you ever observe the sky, you will see lots of these. You will see various formations in the sky, various stars, etc. Right? And then one interesting thing that you'll see is that there's one object in the sky that's doing something really weird. Number one, it's red. And secondly, it moves across the stars this way. Then it changes its mind and goes back. Then it goes this way. Then it goes back. Then it goes this way. Then it goes back. Then it goes this way. Then it goes back. Then it goes this way. It's moving across the stars in this way.
I think they call it retrograde.
Don't talk. I'm building up to the climax here. You're not ruining it. देखो ना क्लाइमेक्स से पहले अगर कोई बंदा स्टोरी बता दे तो सारा मामला खराब हो जाएगा. कहेंगे ओ जिसको कहती ना जिप वो जो कहती ना कि जब आप फिल्म देखने जा रहे थे वो ट्रांसफॉर्मर्स देखने जाते हैं. ओ या बाय द वे या क्या कहते हैं वो नहीं लोग इन्फिनिटी वॉर देखने जाते हैं. ओ या बाय द वे एंड में बैठ गए. फायदा क्या होगा देखने का. So don't get the story. Thank you. Acha, not only is this one, there are others as well who do the same thing. In fact, there's like 5 of them. And they're going backwards and forwards and doing this sort of strange dance in the sky. What's going on? What are these things? Yeah, now you can tell me. What are these things? Comets?
Can I know?
Okay. If you must.
Yeah, this is called retrograde motion, and it's done by the planets.
That is correct. So these were the planets. The red one is the one that's closest to us. That's Mars. And because it was red, when people saw it in the sky, they thought, oh my God, this is the god of war. They actually had Mars is the god of war. And then they had another one which was white, almost pure white. Couldn't make anything out of it, just pure white. And they're like, oh, if that's the god of war, this is the god of love, so they called it Venus. And that's how you get the names of the planets. Actually, all the names are names of gods. Jupiter was one of the chief gods of the Roman religion. So all the Saturn as well. So all the names are actually names of ancient gods. We don't no longer consider them gods, but that's how the names came about. Now, why did if these were angels, these were really gods, etc. Why were these gods? Because they were doing something really weird. They were going backwards, if you observe it. And you're quite right in pointing out that this is retrograde. It's terrible. Retrograde is also used in that way in literature. but it's moving in the opposite direction. So what is going on, of course, is that we know today that what's going on is that they are revolving around the sun, and we are observing them as we are revolving around the sun, moving and revolving around the sun. So their motion, imagine, check this out. Here I am, I'm the earth, and I'm going like this, and I'm going like this, and I'm going like this, and I'm going like this. But if you were doing the same thing, oh my God, that would be so confusing. I mean, like the Milky Way. But if you started doing the same thing, and I was looking at you, and you were looking at me, that's the kind of picture I would end up seeing. This required explanation. What's going on? So the church thought that what's going on is that things are moving in circles, and then these planets are moving in circles around us. So there are circles within circles. And they made these very complicated sort of models to try and predict the movement of the planets. Of course, they couldn't do it. And they couldn't do it not because, for the simple reason that, as I told you, if I'm moving like this, round and round, and you're doing the same thing, and then I'm trying to figure out mathematically where you are, good God, that would make an awfully difficult mathematical equation. Right? It would be very difficult to figure that out. And that's what it was very difficult. So people made many, many models, etc., to try and figure it out. They also tried to relate it to the Platonic solids, etc., tried to relate it to philosophy, and tried to relate it to other things, tried to relate it to religion, but they just couldn't figure it out. They could never get the movement accurately. Then along comes this fellow here, and he looks at it. He is not really an astronomer. He's much more of he looks at all the theories that have been written on the subject. And he thinks, you know what? If we were just to rethink all this and look at the sun at the center and look at us as revolving and the planets are revolving as well around the sun, then this retrograde motion, as you called it, would make sense. It would explain that they are not in fact moving in a circle, around a circle, but that in fact they are moving in a circle, and we are also moving in a circle. And because we are also moving in a circle, and they are also moving in a circle, and the center is somewhere else, then this solves a mathematical problem. That's why we're seeing this retrograde motion. Wow. What an idea. It took about 2,000 years for somebody to come up with that idea, but what an idea. Actually, now, Copernicus was a smart guy. And he knew that if he stated this, that the Catholic Church would probably not reward him, but would be very, very upset. So he decided कि ऐसे करते हैं, इससे पहले कि मैं Facebook पे पोस्ट करूं, ऐसे करते हैं कि उसने किताब लिख ली और उसने अपने ना सेफ में रख ली और जिंदगी अपनी उसने जी ली, मौत मिला किया और जब वो बीमार हो गया and he was on his deathbed, he was old by now, and he knew I'm on my deathbed, I'm not going to survive much longer. Then he said कि यार अपने दोस्त को उसने बुलाया, उसने कहा यार ये मैंने किताब लिखी है, तो मैं तो दुनिया से जा रहा हूँ, तुम इसको छाप देना। तो उसने कहा ठीक है। It was called The Revolution of the Heavenly Orbs, the book. It was about revolutions, how the revolutions can be explained. Heavenly, you understand, in the sky. Orbs means, balls or whatever. So he knew that the church would not be happy with this publication, so he waited till he was on his deathbed before he posted it on Facebook. Before he published it. And obviously, since by that time the printing press had been created, it was published by the press, etc. It was a sensation. It was a sensation because this riddle that had confused people for such a long time, somebody had finally managed to say something on it that could possibly make sense. But there was still a problem. The problem was that if this was true, then now we should be able to mathematically chart the movement of the planets. So this guy Kepler decided that he's going to mathematically try and solve it. By this time, there are certain very important advances in mathematics that occur thanks to Fibonacci, who copies I think Ibn Hisham and others, etc. And the Indian numeral system, which the Arabs take from us, Yeah, the Arabs also learned something from us. ये जो आपने 1 2 3 4 5 6 7 8 9 10 लिखते हैं ना अंग्रेजी में, वो अंग्रेजी नहीं है, असल में वो हिंदी न्यूमरल्स है। और अरब्स ने जब यहाँ पे आए थे तो उन्होंने न्यूमरल्स को स्टडी किया और इधर से उठा के लेके गए, थोड़ा सा उन्होंने आगे पीछे को कर दिया, ठीक है। ये जो हाँ जिसमें आप लिखते हैं ना 2 को थोड़ा टेढ़ा कर दो, उल्टा पुल्टा कर दो, ये अंग्रेजी वाला 2 है, ये नहीं है, क्या है, ये 6 है, हाँ ये, अब ये देखो ये 2 यूं लिखा हुआ है, इसको यूं कर दूंगा क्या हुआ है? तो किसी ने टेढ़ा लिख दिया, बस टेढ़ा हो गया, मैं क्या करूं? पर इस तरह करके, और हमारे पास कई सिस्टम्स थे, इधर जरा मैं आपको दिखा भी सकता हूँ, ये सारे लिखे हुए, ये देखो ना, ये कई सिस्टम्स हैं। ये 2 किस तरह लिखा हुआ है यहाँ पे 3 हो गया है। Anyway, so these were the ये देखो ना, इस तरह करके लिखा हुआ है वगैरह वगैरह। So these were the various systems of writing that the Arabs took from us. So एक बार मैंने अपने ड्राइवर से पूछा, मैंने पूछा ये जो लिखा हुआ है, जो लिखा हुआ था, तो ये ज़्यादा आसान है पढ़ना या ये उर्दू में लिखा हुआ है ज़्यादा आसान है पढ़ना? Actually I use some other word, जैसे ये ज़्यादा आसान है, ये ज़्यादा आसान है। तो उसने कहा सर अंग्रेजी वाला ज़्यादा आसान है। तो एक्चुअली वो अंग्रेजी है ही नहीं, वो बेसिकली हिंदी के न्यूमरल्स भी उन्होंने लिए हमसे, चीटर्स। एनीवे, तो अरब ने हमसे लिए और जो यूरोपियंस थे उन्होंने अरब से लिए। यूरोपियंस पता है कैसे लिखते थे उस वक्त? एक सेकंड, ये बड़ी मजेदार कहानी है। मैथमेटिशियंस तो बैठे हैं यहाँ पे, अच्छा वो लिखते थे 1 2 3 4 5 6, कसम खुदा दी। फिर उन्होंने ये सोचा यार ये तो बड़ा टाइम लग रहा है, अगर 100 लिखना है तो ये तो बहुत टाइम लगता है। तो फिर उन्होंने कहा अच्छा इस तरह करते हैं कि जो 5 है ना उसको यूं कर देते हैं, काट देते हैं, ठीक है ना, और जो 10 है ना उसको यूं काट देते हैं। तो अब जरा आसान हो गया। अब उन्होंने कहा 2 3 4 कैसे लिखें? ये 1 इधर डाल देते हैं और 5 बार डाल देते हैं, 5 - 1 4 5 6 7 8 9 10। कभी इस पे तो आप मुझे जरा मैथमेटिशियन को कागज पेंसिल निकालो और 9 मल्टीप्लाइड बाय 9 करके दिखाओ। हो नहीं सकता। It's like it makes it impossible to do any kind of advanced mathematics. If I ask you to multiply 103 by 104, you would आप सर पकड़ के बैठ जाएंगे, आप समझेंगे मैंने PhD कर ली by the time you do it in this stuff. So the development of 2 very important things. There are 2 very important things. One of course is zero. They have no concept of zero. बिल्कुल भी zero से. Zero, written as a point in Hindi, written just as a point. So this concept of there being zero and a decimal system is actually invented here in the subcontinent. Travels there then to the Arabs, who of course are very clever people and take from all civilizations at that time, and then travels to Italy and so on and so forth, and develops mathematics. So important changes in mathematics have come about. And Kepler meets with another very famous astronomer, Taimur Rahman, who has spent decades of his life collecting all the data and of the movement of the planets. And Kepler takes that data and tries to fit it into a mathematical pattern. And when he does that, he discovers that the mathematical pattern in which they fit is not that the planets are going in a circle, but that they are going in an ellipse. Good God, that was a terrible ellipse. ठीक है ना? And that the time it takes them to travel from one point to another point is the same as the time that it takes them to travel here, and the area over here will always be equal to the area over here. So T over here is equal to T over here. You'll figure out, I'm sure you guys are scientists, you can figure out the formula for the ellipse. He applied it and he got very, very, very good results. So now this is something very new, because till that time, people had thought that these were perfect circles. Of course, orbits are not perfect circles. Even planets are not perfect situations, right? We know this today. It's very obvious. But to have discovered this at the time was something really, very, very, very unique. Uh, right, so I will continue. Before I go to Newton, where's it should have been, right, oh, he's not here, but he's here. So after Kepler comes this guy, Galileo, very smart man. He is discovers many interesting things. For example, he proves that Aristotle is incorrect. Aristotle thought that if you dropped two objects, the one Aristotle सही कह रहा है मेरे ख्याल है कि अगर मैं दो चीजें गिराऊं, जो भारी चीजें वो पहले गिरती है ना, हाथ खड़ा करो जो भारी चीजें पहले गिरती है. Oh my God, you scientists, you're absolutely wrong. क्या हुआ? फर्ज करो एक ये बोतल है और एक ये बोतल है, ठीक है? They have the same plastic, but this one has more water than this one. Therefore, this is heavier and this is lighter. So, if I drop both of them, obviously the heavier one will fall. Ready? Same? ये कैसे हो सकता है? तो भारी है. Ready? So which one gets first? Same? चलो दोबारा करते हैं. ये भारी वाली, लाइट वाली. So the answer, the correct answer, my dear scientists, if you raise your hands, then you need to go back to Galileo. They will fall at the same rate. They do not fall at different rates. The momentum that they carry, F is equal to ma, is the same, is different, but the acceleration that they will get is exactly the same. So, the force with which they hit the ground is going to be very different, but the acceleration that they receive is going to be exactly the same. So when Mr. Galileo was one of the first people he was the first person to discover that Aristotle was incorrect. And how did he do it? Simple. He went up a tower, he took two rocks, one was heavy, one was light, he dropped them. It was a tall tower. And he dropped it exactly the same rate, at the exact same time. And he said, this proved what had been taken for granted for 2,000 years. You know? So this described how Galileo worked. He loved to experiment. He loved to create little experiments that would prove whether he was right or wrong. Similarly, he looked at projectile motion and looked at how things will rise and fall given gravity and their vertical and horizontal velocity. Similarly, he developed with more mathematical precision, with the new mathematics that are developed in Europe, he developed a concave glass, which of course you could use to first just use as a spyglass, but later if you put two in series, you can use them as a telescope. And this was very, very important because with a telescope, you could look out at sea and say कि कौन सा trader आ रहा है, कौन सा trader नहीं आ रहा. ओए spices के आ रहा है, माना, I better get my money ready, etc. It was a very useful device. But then he did something really bad. What he did was he took that telescope and he turned it up. Turned it in the sky. And he started observing the moon, he started observing the planets. He discovered moons around planets. And when he looked at the moon, he said, did you know that there are mountains on the moon? And there are valleys on the moon? And on the moon, moon, you only have one. And so on. And when he made these discoveries, they were scandalous. Oh my God, what is he saying? And the more he studied with the telescope, the more he looked at the heavens, the more he became convinced that the Copernican theory of the heliocentricity of the solar system was correct. It would give the right observation, he could take those observations with his telescope, etc. So he wrote a book. And being a highly honored and highly valued intellectual at the time in Italy, He thought that even if he wrote this book, which was somewhat against the church would not do anything against it, because he had brought enormous. He was a big trader. He was very rich. He was considered one of the most honored citizens of the country, etc., etc. He thought, okay, I'll present both theories. I'll write down what the old Ptolemaic theory is. I'll write down what the Copernican theory is, and I'll leave it to the reader to judge. So he wrote down both theories in his book and presenting the evidence for both of them. But the church did not like it at all, because it challenged their version. And because by this time, you recall, I told you that the church is already in the process of strongly in the grip of the counter-reformation. So these new ideas that are coming about, saying that the earth is not the center of the universe, is an affront to them. As you said, what was this, the phrase you used, कि मतलब पूरी कायनात इंसान के गिर्द घूम रही है या इंसान के लिए ही बनाई हुई है. So this was something which displaced man from the center of the universe, that the universe was not created for man, that this was a cardinal sort of belief habit. So the church invited him for a dialogue first. They tried to stop him from publishing. He said, then they were very upset with him. Then they arrested him. Then they had a trial of Galileo. And in the trial, of course, as it was always happens, they accused him of blasphemy and they accused him of, heresy and so on and so forth. He was very old by that time, so they said, okay, we're going to put you under house arrest. Where they didn't kill him. They had already killed this other guy, Bruno, Giordano Bruno. Bruno had also advocated the same thing. In fact, Bruno was quite remarkable. He wasn't really a scientist like Galileo was, so he couldn't prove his theory. But the things he was saying were just amazing. Like, for example, he would say that there are an infinite number of worlds. And that all these stars that you see are planets like ours, and they may have life on them. I mean, to say that, at that time in history, where people are thinking that these are not planets but they're angels, was something else. It was very radical at the time. And the other thing that bothered people was, well, if the universe is infinite, they would say. He would say, my God is infinite. My God is created, he was a religious person. My God has created an infinite universe. They would say, if the universe is infinite, then where is heaven and hell? Because they had the concept that the fixed stars were at some geographic distance from us, and after the stars, there was heaven and hell. So the universe is infinite. Where would we locate heaven and hell? So at first they imprisoned him, they tortured him, they interrogated him, whatever, etc. He refused to recant. So finally they had a trial for Bruno, and Bruno refused to say. He said, no, my God is infinite, the universe is infinite, and the stars, etc., are planets like ours, and then they have life forms on it, and so on, and the sun is the center around which we revolve, etc., etc. They said these theories, they said, कि या तो माफी मांग लो, या फिर तुम्हें जिंदा हम जला देंगे. Or we are going to cut your tongue out. First we'll cut your tongue out, then we'll put a kala on your face so that you can't scream or shout or say anything, and then we are going to burn you alive. Ab to maan jao. Usne kaha कि in court he stood up and he said, you are more afraid of pronouncing this sentence than I am of receiving it. Go ahead. And that's what they did. They went ahead, they took him to a place, they cut out his tongue, they locked up his jaw, and then they burnt him alive. And that chalk where he was burnt alive, I've been there. It was a garden at that time. Today, there's a monument to him in the center of that chalk, and people sit around and they eat food, and it's a very sort of happy place now. कल की जो क्या कहते हैं उसको, हाँ, जो what's the right word for it? कत्लगाह है, वो आज की तफरीह की जगह बन गई, exactly. So I think that's deliberate by the Italians, that they celebrate Bruno rather than anything. So he was one of the great martyrs of science. So Galileo को उन्होंने जलाया तो नहीं, मगर उसको बंद कर दिया, और after years of his life he started losing his eyesight as well. He was stuck in his house. He said, I who have expanded man's vision 100 times, have lost my own. It was very sad later. The trial of Galileo, however, sealed the fate of what was going on in Italy. Some people say that this is the close of the Italian Renaissance, etc. At least it is the key event that puts the church into conflict with the new science and causes science to rebel from the church. But okay. Then along comes, now the thing is that it's very interesting to say, to be able to predict where the planets are going to be, thanks to Kepler. It's very interesting to say that the planets are revolving around the sun. It helps simplify the entire solar system. But then comes this guy, and he does something even more phenomenal. By this time, Newton, sitting, writing and thinking, Newton is an incredible brain. By the age of 23, he's already made groundbreaking discoveries in optics and in many other things. And one of the secrets that he has, secretive fellow, one of the cool things that he does is he invents calculus and doesn't tell anybody. Check it out. So he invents calculus and says, you know what, I'm going to use calculus to figure out so many different problems, optics problems, shape of the glass, etc., how it's going to refract, all of these things. But I'm not going to tell anybody how I'm getting those results. I'll keep calculus a secret. Of course, the result of keeping it a secret was that somebody else also discovered it, which is Leibniz. And then they both had a fight and said who discovered it first. They both discovered it independently. That's the history. But now Newton, having discovered calculus, also makes another, having worked on optics and then on calculus and then on many other things, makes a groundbreaking discovery, or set of discoveries rather. He writes his famous book Principia Mathematica. In that book, he argues that he elaborates on the laws that Galileo had already mentioned in his book but had not been able to elaborate. Which was, you remember that projectile thing that I did? Now it's gravity that's operating on both the bodies. And the mass, the speed at which, the acceleration at which those things are moving is not related to the mass. F is equal to ma. Now what Newton is able to figure out is that the strength with which two objects attract each other is proportional to their mass, but inversely proportional to the distance between them. The further out you go, the less the strength of gravity. And also he's able to simplify gravity by stating that just take the object and to find that distance, take the distance from the center of gravity of that object. That concept of center of gravity is invented by Newton. So you take it from the center, you look at the distance, and you find out, if you know the masses, you'll find out the force with which you are attracted. So what is it? Big deal. Well, the big deal is, gravity is something you and I understand, because we experience it every day. If I fall off this thing, I will come down. I know nobody has to explain this to me. It's an earthly thing. It's not a heavenly thing. If I could explain how the planets did that, what Kepler was saying, what Copernicus was saying, what Galileo was saying, by a force that I experience here on the earth, that's amazing, because I will have explained something about the heavens by something that exists here on earth. So he used gravity to explain the circulation, the orbit of the planets, because he was able to explain through centrifugal and centripetal forces. Just take a dhaga, put a ball on it, and revolve it, and the speed with which you're revolving it, and the mass of that object, gives you the force that would be used to keep it within that orbit. Having discovered that by, sort of revolving the dhaga here and there, having discovered that, he could now explain not just that the planets were revolving around the sun, but why It used gravity to explain why they were revolving around the sun in the way that they were revolving. Why some took longer, others took shorter, it depended on their mass, it depended on their distance. Exactly. Oh my God. This was like it had such an enormous impact on the world that we have today, precisely because the views of the medieval period were exactly the opposite. देखो आम पब्लिक तो उस वक्त भी ये कह रही थी, न्यूटन के दौर में भी ये कह रही थी कि ये एंजल्स हैं। और वहां से कहाँ आप शुरू हो रहे हैं कि वो एंजल्स हैं, और वहां से आप ये एक्सप्लेन कर रहे हैं कि ये पत्थर है, और ये पत्थर सन के इर्द घूम रहे हैं, और ये पत्थर सन के इर्द इसलिए घूम रहे हैं क्योंकि जिस तरह आप किसी गिरते थे ग्रेविटी की वजह से, तो इसी तरह वो भी घूम रहे हैं ग्रेविटी की वजह से। The philosophical impact of that was that it said that the heavens were no different. It validated Anaxagoras. The heavens, after all, are no different from the earth. The laws that govern the movement of the planets are no different from the laws that we experience on the earth. It proved Bruno right, it proved Galileo right, Kepler right, it proved Copernicus right, and it changed science forever. It was the pinnacle of that particular achievement. Now, this meant that many new ideas, many old ideas that were held dear by the church and by mankind as a whole at that time were being overthrown. These ideas can be summed up if we looked at by the phrase the absolute immutability of nature. They were present in biology, they were present in astronomy, they were present in physics and in many other realms. And they owed their origin to the writings of Aristotle and how the church had understood and interpreted. They were as follows. The planets and their satellites, once set in motion by a mysterious first impulse, circled on and on in their predestined ellipses for all eternity, and these were perfect circles. Stars remained fixed and immovable in their places, keeping one another therein by universal gravitation. The Earth now this was the new discovery. The Earth had persisted without alteration from all eternity. This was the view earlier. Now, suddenly in geology, people are beginning to discover that the Earth itself has a history. Nature has a history. The 5 continents had always existed, and they had always had the same mountains, valleys, and rivers, the same climate, and the same flora and fauna, except insofar as change or cultivation had taken place at the hand of man. The species of plants and animals had been established once and for all. These were the views of people at the time. It was how nature was basically static. In their view, nature did not change. And now all these new views were being introduced that were challenging all of these older, 2,000-year-old assumptions. This began the movement by philosophers for the liberation of science from theology. And one of the key figures in the liberation of science from theology is this guy called Baruch Spinoza. For the Greek philosophers, the world was essentially emerged from chaos, but for the scientists of that period, nature was ossified, something immutable. And for most of them, something that had been created at one stroke. Because, the Bible said, God said, let there be light, and then there was light. So there was no history of light. There was no history of how the universe was created. It is to the highest credit of philosophy of the time that it did not let itself be led astray by the restricted state of contemporary natural knowledge, and that from Spinoza right to the great French materialists, it insisted on explaining the world from the world itself and left the justification in detail to the natural science of the future. It did not have the requisite necessary scientific data and instruments to be able to explain why these theories were wrong. So the first development of these new theories, that the world was always in motion and change, and it was the task of science to figure out the laws of that motion. The motion, the world was in change not as a consequence of the will of God, but as a consequence of the properties of those objects, gravity, resistance, and so on and so forth, friction, whatever we're looking at, depending on mechanics or whatever. Why is this a problem? For you, it's not a problem anymore because you're in the 21st century. Why was this a problem? Well, it was a problem for the same reason that it was a problem for Al-Ghazali. Al-Ghazali, if you've read him, argued against this idea that the world operated according to its own natural laws, because he felt that if we accept this doctrine, then we, in effect, take away many of the domains from the power of God. We restrict the power of God. We are not accepting the doctrine of the omnipotence of God. If God is all-powerful, Al-Ghazali argued, from that premise, it should follow that everything that happens in the world happens as a consequence of the will of God. Now, if I'm arguing that this is going to fall not because of the will of God, but because of the nature of matter, for the theologians of that time, ये एक unacceptable proposition. How could God not be intervening in the way in which this thing is falling? This doctrine was called occasionalism. What it said was, and this is how Ghazali puts it, that no, this thing falls to the ground because of God's will. If it always falls to the ground whenever I release it, it is because God always wills the same thing. But if God wills something different, it would not fall. And that would be what we call, quote unquote, a miracle. This also meant, of course, that God must be creating and recreating the world, says Ghazali, in every instant. Every molecule, every atom, every quark, of course they didn't have a quark atom. But anyway, you get the point. Every single particle of the universe was being, in every single instant, was going away, coming back. And this was in accordance with God's will. If that was the case, then there could be no such thing as laws. There could be no such thing as continuity, because there could be no such thing as causation. Because causation, philosophically, requires that a thing exists from one instant to the other. But in between two instances, if it disappears and comes back, then the same object, in a certain philosophical sense, does not even exist. And therefore, there can be no causation. And everything is according to the will of God. There is no cause or effect. There is no, or other to put it this way, there is no necessary connection between cause and effect. Every occasion is sort of recreated. This is captured in the very common phrase that we use, कि खुदा की मर्जी के बगैर पत्ता भी नहीं हिलता. So that's the expression. But you never gave it second thought. You probably thought, कि अच्छा है, everything. So this means that everything happens because God wills it. But this was taken quite very literally. That if everything happens because God wills it, it is taken quite literally to mean that there are no such thing as natural laws. So this is the main problem for science at the time. Because if you believe that laws नहीं हो सकते nature के, matter के, जिस चीज को आप study कर रहे हैं, उसकी कोई कानून नहीं है, as such. तो फिर obviously आप उस कानून को तलाश नहीं करेंगे. You're not going to spend a lot of time and effort looking for a thing that you believe cannot exist. And this is one of the reasons people say that Islamic science and philosophy slowed down or petered out, because they were no longer examining the material world and its causes and the logic underlying the material world. So the same philosophy is held by many other people who are not necessarily religious. For example, David Hume also argues the position that there is no such thing, there is no necessary connection between cause and effect. And this is obviously for science, this is a really big problem, because the whole purpose of science is to discover what? Laws. Right? Okay. So you get the picture. So when Newton says that all the heavens are operating according to the laws, and he proves it with his calculus to the last decimal place, he's really able to, remarkably prove it. It causes a very, very important and a big, big clash. In other things in life, abhi cheezein develop in other aspects of knowledge, in other fields of knowledge. As I said, this scientific apparatus, the data set, has not yet been created for people to solve these problems. But philosophers now begin to think, to imagine into the future. They begin to use their imagination. Now that they've come to this conclusion that there are laws, and they operate, and it's like a clock. They gave it a metaphor. It's called, this philosophy, in religious terms, is called deism. The belief that God has created the world like a clock, set it in motion, and now the clock is turning, and those are the natural laws. God is not interfering in those natural laws as they operate. So this deistic doctrine became very, very common amongst many, many philosophers and many, many scientists. And so they are now discovering the laws of this clock. So now Spinoza and people like Spinoza and other scientists, they begin to just imagine what would be the law of the development of species. What would be the law of the development of the human body, the circulation of blood, how the organs work, etc., etc. The whole focus becomes, I don't know what the law is, but let's first imagine what it is, and then try and discover what it is and what it isn't. So this is a radical rupture. But by about the time that this guy comes about, Immanuel Kant, many people say Immanuel Kant, but actually his name was Immanuel Kant. वो बड़ा क्यूट सा मीम है कि जिसमें वो बाबा खड़ा होकर कह रहा है yes we can, और उधर Immanuel Kant खड़ा होकर कह रहा है no we can't. So it's very cute. Kant was a German, but he lived in Königsberg, which is in Russia today. And he was also quite fascinated. He was torn between these two worlds, as lots of people were at the time. On the one hand was this new Newtonian world, which was fascinating, and he was too sophisticated and intelligent a person to completely ignore it. On the other hand was his beliefs in Christianity, his ethical views, etc. And in particular, one view which he was very important. Here's the second big problem about science. If everything operates according to a law, according to logic, what about human will? If everything operates according to a law, what happens to human will? Is it deterministic? Your brain is made up of little synapses and so on. You have a circulation of blood which already had been developed at that time. Your blood carries the oxygen which feeds your organs, etc. You're like a little machine. A very sophisticated one, but a machine nonetheless. And you know something about machines. Machines have a code, and they obey that code. They do exactly what their code tells them. What's your code, and are you obeying it? If you are a little machine, or a big machine, strong guy. If you are a little or a big machine, now, what happens to free will? You're doing what you're programmed to do. And if you're doing what you're programmed to do, this creates another very big problem, which is the problem of morality. If you're doing what you're programmed to do, then you're not exercising free will, then of course the fact that you cheated on your last exam, you have to say to yourself, actually, you see, Dr. Taimur Rahman put that we like machines. We are programmed to do what we do. So I'm programmed to cheat on your test. And so you can't really blame me for cheating on your test because I'm programmed to do it. I'm just obeying the laws that are inside of me. So if we're also doing what we're programmed to do, then nobody can be punished for the things they're doing in heaven or hell or even on this earth, etc. So where is free will? Kant thought this is a mess. Oh my God, this is a huge mess. How do we reconcile the Newtonian mechanistic view of the world, which obeys natural laws, with human free will? We are part of that natural material world. This is, by the way, a problem we still have not solved. So if you find this a difficult thing, well, all we've done is we've said, oh, that's like so natural science and this is like social science. In natural science, we obey laws, and in social science, God knows what we do. So, that's how we reconcile it. But that's not a good reconciliation. That's not a logically sound reconciliation today. Just have this bifurcation because we are part of the material world. So this is a problem. So Kant solves this by saying, really bringing the scientific revolution to a close. He solves this by saying, there are no facts. What? There are no laws and there are no facts. Everything that we observe through our senses, and through by looking, by touching, by feeling. And our senses, our brain has a certain transcendental features. Transcendental means they always existed. They're not material. They transcend the material. We call this transcendental idealism. And whenever we look at the world, we look at the world through the prism of those things. So we do not know the thing in itself, and we cannot know the thing in itself. If you are the thing in itself, I really don't know if you exist even, let alone if you're smiling at me. I can't know. Whatever I know about you are things that my mind has put outside. So time is not actually, it may actually not be a concept. It's a concept that was programmed into our brain from the beginning. We think that we're experiencing the world in terms of this linear time. Space is not something that was developed as a consequence of touching and feeling and moving around, but it's something that's pre-programmed in us, and then we look at the world in terms of space and movement and so on. Change, all of these things. This is like super crazy stuff, right? Super interesting, but super crazy stuff. And therefore, there could be no absolute knowledge. And if there could be no absolute knowledge, then this whole situation with the science claiming to be absolute knowledge, or even religion claiming to be absolute knowledge, is now up for questioning. And you see that Kant is hugely influential in European philosophy. And you can see directly the influence of Kant in postmodernism, in subjective relativism, and in many other domains of philosophy and social science. So this basically brought the philosophical adventures or the adventures of various philosophers/scientists to a deadlock. But just to point out to you some very interesting things, geology had already showed how the earth was made in layers. It had developed. This was a big thing. Cuvier had placed, in place of a single divine creation, he put a whole series of repeated acts of creation. Lyell first brought sense into geology by substituting for the sudden revolution. It created the gradual effects of the slow transformation here, etc., etc. So now every scientist is talking not about the sudden creation of something, but the history of the earth, the history of the rivers, the history of the seas, the histories of the planets, and so on. Similarly, the same transformation occurs in physics, where Meyer in Manchester demonstrated the transformation of heat into mechanical energy and mechanical energy into heat, thus proving that these are not two different forms of energy, but the same. Group proved that the so-called physical energy, mechanical energy, heat, light, electricity, magnetism, chemical energy became transformed into one another under definite conditions without any loss of energy. And so proved Descartes' principle that the quantity of motion present in the world is constant, that energy and matter, the amount of energy and matter is constant. Later, Mr. Einstein gave an equation for this. E is equal to mc squared. Energy translates into matter in a very definite proportion. Physical energies were resolved into variously differentiated forms of the motion of matter, convertible into one another according to definite laws. The existence of a number of physical energies was abolished from science by the proof of their interconnections and transitions. And this process is still going on. They finally ended up with 4 key energy forces. They had electricity and magnetism, and then they were combined into electromagnetism. They had gravity, and they had the strong nuclear force and the weak nuclear force. And those are absolutely essential to explaining how protons, electrons, and neutrons stay together in an orbit and at that microscopic level, electroscopic level, or whatever you want to call it. How do they stay together? You can't explain it without strong and weak nuclear energy. And what was it that Abdul Salam was working on, for which he received the Nobel Prize, for which?
Electroweak force.
Sorry?
Electroweak force.
Yes, so he's combining the electromagnetism with a weak nuclear force, and he develops, along with 2 other scientists, proof that they are one and the same. So what is science therefore coming to? It's coming to what is called popularly the theory of everything. What does that mean? It's not the theory of why I had coffee just now. It's a theory, it means that all the force that we experience in the world is one force. And we have to find out ways in which this strong, weak, nuclear force and electromagnetism can show to be the same force. Chemistry similarly, oh God, I should not be speaking about chemistry. You will probably swim circles around me on this one. But Lavoisier and Dalton create organic substances from inorganic compounds. And they bridged the gulf between what was at that time considered organic and inorganic chemistry. Biology similarly sees many new developments. The separation of species of plants and animals. Animals turned up, new animals, the discovery of new animals. There are organisms that cannot be categorized as animals or plants. Wolff in 1759 launched the first attack on the fixity of species and proclaimed the theory of descent. Then Oken, Lamarck, Baer, and finally Darwin in 1859 victoriously carried through this idea that nature was constantly changing. हम इसको और तनाज़ुर में देखते हैं पाकिस्तान. हम डार्विन को अगर अपोज करते हैं तो हम अपोज इसलिए करते हैं कि we think we actually in our own history, interestingly, before Mr. Darwin came about, Ibn Khaldun also talks about change in evolution of the species. Very remarkable. And so the idea that species undergo transformation is of course not necessarily something new, because people who were breeding horses, breeding animals, etc., breeding dogs, knew that if you crossbred, two dogs of different species, you get a third species and so on. They knew this. And they were deliberately intervening to create new species and so on. So horses is the same thing. We other Arabs were very fond of horses. So they would get horses from Mongolia and they would breed them so that they would get the biggest and baddest horse they could possibly get, the strongest one, etc., etc. So this was known to mankind that this can happen. But what Darwin introduces is the idea of the evolution of the species being driven by natural selection, which is a new thing. For his time, though, we think of this in terms of, okay, Darwin is challenging the church and challenging the conception of how life was created, whether it was created, by Adam coming down from the Garden of Eden, or rather being expelled from the Garden of Eden, etc., etc. So we take this in a theological direction. But the actual sort of debate is, the context of the broader debate is whether the world is static, metaphysical, or whether the world, as we know it, the material world, is in constant change and motion. What these theories, all of them together, are arguing, the philosophical point that they're arguing, that they've come to accept from philosophy, is that everything is always changing. Change is the only constant. So we see, therefore, that nature is shown as moving in an eternal flux, a cyclical course that lasts for billions and billions of years. And of course, the discovery of ancient fossils of other animals that no longer exist was also, a huge thing. Achha, by the way, आपको फिल्में देखते हैं ना, क्या नाम है, ड्रैगन्स की फिल्में, वो गेम ऑफ थ्रोन्स में भी तो ड्रैगन्स हैं. So what accounts for how did mankind come up with the idea of dragons? I think mankind probably came up with the idea of dragons. The Chinese probably are the people who came up with it. When they discovered certain dinosaur bones and they could not identify what kind of animal it was. So they created an animal which they thought was a mythical animal, which was a dragon. They thought it would, spout fire and so on and so forth. So क्या मतलब आप ये कह रहे हैं dragons don't exist? This is terrible news. Okay, so science now in a certain sense returns not to Greek science but rather to Greek philosophy, because it was the Greeks that had intuitively grasped that all things that exist are constantly undergoing motion. Everything is changing. Nothing is static. Everything moves. Everything comes into being and dies, including you and including me. And this idea of the evolution of matter and constant evolution of matter and life, and the historical evolution of man, the changes that have come about in our lives, is referred to as dialectics. Please write that down if you will. Dialectics. The movement forward in philosophy is called dialectics. The movement forward, the change in development that occurs as a consequence of internal contradictions. And so when this idea develops, it finally sees its most profound development in the 18th century, etc., it now is transferred from the realm of science, philosophy, and nature into the realm of human affairs. It's not only the case that plants, animals, etc. have a history, but humanity too has a history, not just in the sense of lots of events taking place, and also not in the sense that history goes in a circle, but that this history does seem to go in a circle. But this is a very two-dimensional picture. A three-dimensional picture is that history goes in a circle that's moving forward. And what do we call a circle that's moving forward? A spiral. So history goes forward in a spiral. So it was the task now, perhaps, of social scientists and historians to not only understand the circles of the rise and fall of civilizations, as Ibn Khaldun had done already, but even more importantly, to understand the forward motion of humanity that underlay the rise and falls of civilizations. How has humanity progressed, developed forward, and gone to a new and more advanced stage? Finally, how much time do we have for this session?
We'll finish at 1.
Okay, so I come to a conclusion. Finally, we come to the philosophical point of view that all that comes into being deserves to perish. Millions of years may elapse. Hundreds of thousands of generations be born and die, but inexorably, the time will come when the declining warmth of the sun will no longer suffice to melt the ice thrusting itself forward from the poles. When the human race crowding more and more about the equator will finally no longer find even there enough heat for life, when gradually even the last trace of organic life will vanish, and the earth, an extinct frozen globe, like the moon, will circle in deepest darkness and in an ever narrower orbit about the equally extinct sun, and at last will fall into it. What an optimistic idea! What a, sorry?
It sounds like Ghalib.
It is absolute Ghalib. Slit your wrist time, people, because in the end, the earth is going to fall into the sun. That will be the end of that. All right. On that note, I think I'll stop there. I hope you enjoyed that lecture. Thank you so much.